Today we're going to introduce and discuss complex numbers. Okay, a complex number is a two-dimensional number of the form z equals a plus bi, where a and b are real numbers and I is such that I squared is equal to -1. Before we move on, why do we even bother with complex numbers? Okay, complex numbers have a lot of applications in real life. They have applications in physics, electricity, quantum mechanics. They have a lot of applications. These numbers were introduced so that a lot of equations will have solutions, and the interpretations of the solutions are different with complex numbers than they're with real numbers. Don't think of these numbers as the numbers you're used to, like 1, 2, 3. If somebody says I'll give you $10, you know what that means. But if I gave you a complex number like this, like z1 equals 10 plus 2i, then treat it as a complex number. It's not like the numbers you're used to. And then I is a number such that I squared is equal to -1. Complex numbers are very easy to work with. What we need to do, we need to learn how to add them, subtract them, multiply them, divide them, and work with them. We'll start with addition. Let's take two. Well, first, before we do addition, let me give you some examples of complex numbers. Here are some examples of complex numbers. Z2 is 4 plus 2i. If somebody asked you to put this on a number line, it doesn't make sense. Complex numbers are put on a plane like this one. Okay, Z2 is 4 plus 2i. This line here is called the real axis. And this line here is called the imaginary axis. We're used to call it the x-axis and y-axis. So this is called the imaginary axis. Okay, the first number, a, is called the real part of the complex number. I'll write it in a minute. And the second number is called the imaginary part of the complex number. So a is called the real part of z, we're calling it z, and then b is the imaginary part of z. So this number here, z2, is 4 plus 2i. Its real part is 4. So you go 4 units in the real direction and 2 units up. So you go 4 this way and then 2 units up. So z1 would be here. I'll highlight it in red. So z1 is this number. 4 plus 2i is not the same as 2 plus 4i. 2 plus 4i, z3, has a real part of 2 and an imaginary part of 4. So you go 2 units this way and 4 units up. So that number here is z3, and this one was supposed to be z2. z4 is -1 plus 3i. So -1 plus 3i. So you go 3 units up. So it goes up here. If a complex number does not have a b, if its b is 0, for example, if a complex number is 5, then that's a real number. You put it on the real number line. z5 equals 5 would be 1, 2, 3, 4, 5, so that would be here. I'll highlight it. And z6 is 5i. 5i is a special type of number. It's called a pure imaginary number. That means it doesn't have a real part. z6 would be on the vertical axis, which is the imaginary axis. So you count 5 units, 1, 2, 3, 4, 5, and then z6 would be there. For addition and subtraction of complex numbers, let's take two complex numbers, z1 and z2. z1 is a plus bi, Z2 is C plus DI. When you add them, you cannot mix the real and imaginary parts. You add the real parts together, the imaginary parts together. So for example, Z1 plus Z2 would be A plus BI plus C plus DI. And you combine A and C, so this would be A plus C. You don't have to put it in parentheses, but I'm going to, plus B plus D I. So the real part of the sum is A plus C. The imaginary part of the sum is B plus D. And for subtraction, Z1 minus Z2, it'll be A plus BI minus C plus DI. I'm going to put this in parentheses. Okay, so this will be A minus C plus B minus D I. When you're adding these complex numbers, let's do these examples. 6 plus 3i plus 2 plus 4i. We're going to add 6 plus 2 plus 3i plus 4i. 6 plus 2 gives us 8. 3i plus 4i gives us 7i. Done. And for subtraction, let's subtract the same complex numbers. 6 plus 3i minus 2 plus 4i. So it will be 6 minus 2 plus 3i minus 4i. 6 minus 2 is 4, 3i minus 4i is I. When you add complex numbers, you could be adding a complex number here to another one here and then get the result here or anywhere. Not like real numbers. In real numbers, when you add numbers on this line or subtract them, you always get the result on the same line. But with the complex numbers, when you add or subtract or multiply or divide, your result can be anywhere. Multiplication of complex numbers. When you multiply complex numbers like AI and BI, we're going to do longer numbers in a little bit. You multiply A times B and then I times I. But I times I is I squared. And I squared is equal to minus 1. So this is equal to AB times negative 1, which ends up being minus AB. That's how you multiply them. What if you multiply, okay, I by I by I? This is I cubed, right? We can write I cubed as I squared times I. I squared is negative 1, so this is negative 1 times I. So I cubed is the same as minus I. I to the fourth would be I squared times I squared, which is minus 1 times minus 1, and that's equal to 1. I to the fifth, you can write it as I to the fourth times I, but I to the fourth was 1, so this is 1 times I, which is I. And I to the sixth, you can write it as I squared times I squared times I squared, which is negative 1 times negative 1 times negative 1, and that's negative 1. And the way it works is like this. I to the power 0, I to the power 1, I to the power 2, 3, 4, 5, 6, I'll do 2 more, 7, 8. Okay. I to the power 0 is always 1. I to the power 1 is I. I squared was equal to negative 1. I cubed, we did I cubed earlier, was negative I. And this cycle repeats. I to the fourth is also 1, I, minus 1, minus I. 1, if we did I to the power 9, it would be I, minus 1, minus I. And that's how you can simplify these. When you multiply complex numbers in general, like A plus BI times C plus DI, you use the same method we learned, FOIL method, for multiplying binomials. For example, if you're multiplying 2 plus 3i times 4 plus 5i, you multiply each of these by each of these. So 2 times 4 and 2 times 5i. 3i times 4 and 3i times 5i. Here it is. 2 times 4, 2 times 5i, plus 3i times 4, plus 3i times 5i. 2 times 4 is just 8. 2 times 5i is 10i. 3i times 4 is 12i. 3i times 5i is 15i squared. We can combine these two terms for now. 10i plus 12i is 22i bring the 8 down. But I squared is equal to negative 1. I squared is negative 1. So 15I squared is 15 times negative 1. Okay, so 8 plus 22I plus 15 times negative 1, which is negative 15. 8 minus 15 can be combined, and that will be minus 7 plus 22I. So the product of these two complex numbers is minus 7 plus 22I. If you have a complex number that we call a plus bi, if you change I to minus I, we get what's known as the complex conjugate. Complex conjugate. And the notation is z bar. Z bar is a minus bi. Okay, so the complex number is a plus bi, its complex conjugate is a minus bi. Okay, when you multiply a number by its conjugate, z times z bar, the imaginary part will cancel. For example, 4 plus 3i times 4 minus 3i, when you multiply these, the imaginary part will cancel. 4 times 4 is 16, minus 12i, plus 12i, plus 3i times minus 3i is minus 9i squared. And the imaginary part cancels. That leaves us with 16 minus 9 times the minus 1, which is plus 9. And that's 25. So the answer is 25. For division of complex numbers, if you're dividing a plus bi over c plus di, you turn the division into a multiplication. You multiply both numerator and denominator by the complex conjugate of the denominator. So that the denominator is c plus di, so you multiply top and bottom by c minus di. So the top is a plus bi times c minus di, the bottom is c plus di times c minus di. Let's do an example. In this example, we have 4 minus 3i that we're dividing by 5 minus 2i. The conjugate of the bottom is 5 plus 2i. So you multiply top and bottom by 5 plus 2i. And now we have to do two multiplications. So 4 times 5 is 20, 4 times 2i is 8i, minus 3i times 5 is minus 15i, minus 3i times plus 2i is minus 6i squared. And then the bottom would be 25 minus 4i squared. And remember, when you multiply a complex by its conjugate, the two middle terms cancel. Okay, 8i minus 15i is negative 7i. I squared is negative 1. So you got 20 minus 7i minus 6 times negative 1. And then down here it's 25 minus 4 times negative 1. Minus 4 times negative 1 is plus 4, 25 plus 4. And this turns into a plus 6. So it's 20 minus 7i plus 6. 20 plus 6 is 26 minus 7i over 29. That's the correct answer. We can split them up and write it like this. We can write the result like 26 over 29 minus 7 over 29i. So that's what you do when you're dividing two complex numbers. You always multiply top and bottom by the conjugate of the bottom.